Hi, Sir Callan. Hi, everyone. Good afternoon. Hi, Sir Callan. Hi, everyone. Good afternoon. I guess we only have 2 minutes left, and we're still waiting for a lot of participants for this seminar. So kindly just stay put and we'll start the program shortly. Hi, sir.
Hello.
We still have a lot of registrants we're waiting for, sir. Okay, so while we're actually waiting for the rest of participants, Marian Garcia left a message to everyone. Hello, everyone watching and listening from STI College, Batangas. Hi, Marian. Good afternoon, and to STI College, Batangas. Um, I guess we have 103 participants right now. Yes, please do drop your college, like university names, college names. STI Fairview College is also here. Hi, Mr. Arcelia. Yes, there's a lot from STI College Fairview. From what other schools are the students here or professors as well? There we also have from PUP. I guess I've read it somewhere. Yes, watching from PUP Unison Quezon branch. Hi. And greetings in the oneness of heart of Jesus and Mary. That's right. STI College Batangas, STI College Fairview. There's a lot. Oh, okay. We also have one from Ateneo de Naga University. Watching from Lorma Colleges. That's Adrian. And from the La Salle University. That's great. Welcome to this afternoon session. We also have from MSU and from Southern, all the way from Eastern Visayas. We have one from Southern Leyte. So this is like we're going national, not just from Luzon, but we also have from Visayas. That's really great. And we also have Roy from International British Academy. Hi, Roy. Yes. So there's a lot of schools. Who's excited for this seminar? Can I see like an emoji sign, a clap sign? Meepo, yes. Jesus, are you excited? That's great. Yeah, okay. There's a lot of excited people out here. Yes. Okay, that's great. And we also have from Nueva Ecija, Our Lady of the Sacred Heart College of Gimba Incorporated. Welcome to the Enablement Seminar of PSIA. We'll be starting in 3 minutes. Sir, can we start in 3 minutes?
Sure.
All right. So we'll start at exactly 4:05. So while we're waiting, just keep on dropping off your college names in the chat box. and at least we could acknowledge your schools as well. Okay. From DLSCSB, Dallas. Okay. Hi. That's really nice. You're excited to acquire knowledge from today's session. Okay, that's great. Good afternoon to De La Salle University. Again, University of the Cordilleras as well. Ateneo de Naga University, PSU, Urdaneta City Campus. Hi. Hi to University of Makati, Angelica Ramos. Hi. Very glad that you all are free this afternoon to join us, and I'm pretty sure you're going to be getting a lot from this one. So, okay. Is everyone excited? Yes, I'm seeing a lot of emojis when I ask like if everyone is excited. Good afternoon, taga Bukid here. Yes, ako din, taga Bukid pud ko. So, don't worry, you're not alone. We also have from Agusan del Sur. So once again, good afternoon, everyone. And as we are actually being joined by a lot more of participants in this session, my name is Cyril, and it is a pleasure to welcome you all to our 55th, 45th Enablement Seminar, where we will focus on the teaching code quality. So before we proceed with our invocation and the singing of our national anthem, there are a few reminders for our webinar today, and these are that all participants' videos and microphones are disabled all throughout the duration. And also kindly use your full name so that we can address you properly when reading your questions. Don't forget that there will be a Q&A portion after each topic of the presentation or discussion. So kindly send in your questions. We don't have the Q&A section, so please drop it on the chat box. Otherwise, you can also raise your hand and perhaps we can accommodate your question on live. Should a participant want to personally say a question, so don't forget to raise your hand on that so we can enable your microphone as well, okay? The speakers might post questions as well, so don't forget that we have the chat box so that you can communicate through the chat box as well. So this seminar is being recorded by the Secretariat. All right. Now may I request everyone to put ourselves in the presence of the Lord for the invocation.
Lord, thank you for this day, for the presence of everyone in this call. For once again, we are gathered and given the opportunity to appreciate life and your words. Forgive us for our shortcomings and cleanse our hearts as we learn and live your words and example. Father, bless our endeavors, especially today's meeting. May you guide us in our discussions, and may you enlighten our minds in every decision that we make. Give us your grace that we may effectively do our parts for your greater glory. All this we ask in Jesus' name. Amen.
Mga kababayan, ang pambansang awit ng Pilipinas.
Kayang magiliw, helas ng sinakanan, alam ng puso, sa titik mo'y buhay. Lupang hinirang, tuyag ka ng magiging, sa manlulupin, di ka pasisikin, sa nagagang tutok sa simoy at sa langit mong pagaw, ay tinagang tulad, awit sa pagkayang minamahal. Ang isang ng matawad mo'y tagumpay na nagtitingin, ang bituin at araw niya kailan pa may di magtitingin. Luman ang araw ng warhabing pagsinta, buhay langit sa piling mo. Ang inigaya na pagkay mga api, ang mamatay ng dahil sa'yo.
All right. So once again, good afternoon to all of you. Are you excited? Yes. Okay, great. I'm so glad that we actually have a very responsive group. So, every once in a while, catastrophic software development failures hit the news. The deadly crashes of the Boeing 737s, financial software that causes losses in millions of dollars, or even the medical software that recommends wrong dosages. So, what doesn't hit the news is how the vast majority of software development operations are plagued with an increasingly slow delivery and an increasing number of bugs. This is because many software developers are not prepared to handle the complexity that grows exponentially in any code base. This seminar will cover some of the basics in quality in code, including defensive programming, cohesiveness, ubiquitous language, and test-driven development. So we are honored to have with us an expert and a successful tech entrepreneur. Our speaker is particularly keen on test-driven development, domain-driven design, and a lot more of code quality practices. So I'm sure that everyone's excited, as you said. So without any further ado, please give it up for the co-founder and CEO of Orange and Bronze Software Labs, Mr. Callan Legaspi.
Hi, everyone. All right, can you hear me?
Yes, sir.
All right. Okay, let me share my slide. Okay. All right. All right. So yeah. So let me pose a question. For those that haven't worked in the industry, in the software development industry, how do you think? What are the more salient things that are different in school programming versus real world programming? How do you think? Uh, any guesses on how you think the experience in school in the academe is different from the real world? Any? There was a lot of feedback before, but now everyone's gone. No proper scaling of users. Yeah, that's true.
I don't know, but I'm pretty sure they're similar.
All right. Anyone? Unstructured workflow, version control. All right.
It's hard, Sir Callan.
Yeah. Standards of coding.
School have limited teaching of codes unlike in real world.
All right.
There are a lot of programming languages the school haven't taught us.
Okay, use of conventions, application. All right. Individual versus collaborative, right? That's true. More complexity, more complex applications, proper code principles, structuring. Uh, all right. Okay. So, for one, um, the in school you do a lot of writing code, but in the real world you spend a lot more time reading code than writing it. So you actually don't. Yeah, you spend more time reading. Could be your own code, but most of the time it's other people's code and trying to understand other people's code than writing. All right. Um, and the other thing that a lot of people find very different, um, for those that just joined the industry, is that is the amount of change that happens in software development projects. All right. So it's in school, it's very rare that a requirement in a software project changes, but it in the real world it's constantly changing, right? There's the requirements change almost in you know in consistently, right? There's a big word that we use in the industry called maintainability. And in a nutshell, it just really means that the level at which code is easy to read and the level at which code is easy to change. Okay, so when they talk about maintainability, um, it's just about code being easy to read and to change. Right? There's another term that we have in the industry called technical debt. And so that's basically the opposite of maintainability. So as code as a code base grows, right, you expect that things become more complex, more messy, and it becomes harder and harder to understand and harder to change. All right. So what are the effects? Team members, it takes a long time for if you introduce a new member of a team. I've heard stories where it takes 3 months for a new member of the team to get productive on a code base because he has so much to untangle and understand. um, and the even if a team member has been part of the team for a long time, he will have a hard time taking over the work of another team. Say there's something that needs to be fixed urgently, but this other team member went on vacation or even worse, left already, resigned or was reassigned. It's very difficult for programmers to take over somebody else's work, even if they work for the same on the same team. And code becomes harder and harder to change because when you uh, even in small programs that you work in school, you sometimes you touch one thing and something else blows up. And it's the same, and it's even worse in large real world code bases, right? It's unpredictable where it's unpredictable um, where a bug is going to be found, right? So you make a small modification, you think nothing's gonna happen, and then something else completely unexpected blows up. So changes end up introducing bugs elsewhere. So it becomes very, very hard to change software, right? So how does technical debt look like if we use the metaphor of pipe to represent the capacity of a team, right? So we can imagine in this pipe, on one end the requirements come in and on the other end features go out. When there's no technical debt at the start of a project, there's people are just they don't have any legacy code, they're starting a new project, they're very, very productive. So requirements come in, um, requirements come in, and then there's uh, the whole team's capacity i- is devoted to turning the requirements into features, right? Then normal, there's some bug fixing that happens, uh, but and that starts to take some of the capacity of the team, right? That's still normal. But then there's technical debt. So why is it called technical debt? Because like the debt metaphor is, you say you want to do something and you're in a hurry. You don't want to take the time to save and invest, so you borrow money, right? And then you can enjoy your trip, or you can your new car or whatever. um, but then you have to pay it back with interest, and then so everything else becomes difficult and slower, right? Maybe you got faster somewhere, right? You were able to buy a car instead of waiting, but then it, everything becomes slower because you're paying back interest. So it's hard. It becomes harder to save for the next thing. It becomes harder to pay for the things you need day to day. Um, and so that's what happens basically with software development. So people aren't doing the right practices to keep their code maintainable, right? They take shortcuts. They're in a hurry. They initially want to get to deliver some features quickly, but then eventually all that um, all those shortcuts give them code that's very uh, poor to maintain, and then it becomes eventually their productivity eats away at their productivity. So at some point, just dealing with the technical debt and the growth in the bugs, that's um, part of the result of the technical debt, leaves very little of the capacity of the team available for turning requirements into features. So the team is just dealing most of the time with technical debt and bugs. And in our consulting practice at ONB, we've already seen so many companies get to this point, and then even some multinationals eventually needed to close, to really to shut down because they could no longer economically deliver on their software. Um, so here's an example of a real project. Um, so it's over four. This is over 4 months. The green line is tickets being opened. The red line is tickets being closed. So initially, the first 2 weeks, there was no code yet. So as soon as a requirement was specified or ticketed, the team would finish almost immediately on the same day, accomplish the requirement. But at the as things got wide as time went by, in just 2 weeks they already ended up having code that was difficult to read and understand, that it took longer and longer for them to close requirements. All right, so in at the end of 4 months, it took a lot of time to close new requirements, and it looks like it's just getting wider and wider, right? Um, so from an economic standpoint, from the point of view of the business, right? So a lot of businesses, they think software development, oh, they'll do the coding for a while, and then maybe there will be some costs into deploying and introducing, and maybe there'll be some changes, but that's we'll just be spending the bulk of the costs will just be that. But that's not true. In reality, the bulk of the costs of software development happens after the release of the software. All right. So here, this green line here is so here it's sales volume, but you can also replace that with some benefit people are getting from the software. So here people still want to buy the software and people still want to pay for the software, but it gets to a certain point where the maintenance costs, the continued maintenance and development costs of the software, because the cost grew so fast, they just had to keep adding more and more developers into trying to deal with the messy, unmaintainable, difficult to use code, that um, the costs exceeded the sales. So lugi na sila. They were losing money. They eventually software companies lose money on software, even if people are still willing to buy the software, because um, because the the cost of developing and maintaining software exceeds uh, exceeds the sales, the money they're getting from the software. All right. All right. So if we are able to improve the maintainability of software, we can continue the economic viability of the business, right? If we're not able to manage the maintainability, the business dies. If we manage the maintainability, the business continues to survive. Again, we've seen a lot of businesses die because of um, poor maintainability of their software, right? Uh, so bugs, they not only you think buggy software. Maybe every once in a while there'd be something in the news about the 737 crashing, or companies because of a software bug. Like so many things happen. So many stories that I whether they're in the news or not. Some companies could be spectacular, losing millions of dollars, giving things away, or losing money because of software bugs. Um, but actually, I see it happens all the time. Uh, companies losing millions of pesos to millions of dollars. It happens so much more often than you think. It's practically a daily occurrence. Um, so currently I'm teaching. Part time, I teach some software engineering classes, and I cover. So when I teach software engineering, I focus on maintainability, code quality. So at the core, I try to cover topics like simplicity and organization, inclusive of domain modeling, defensive programming, test-driven development, inclusive of refactoring, and version control practices. If the school provides me with more time, I also cover some other some other topics. All right. So just the super shortcut version of what I cover: simplicity and organization. Um, so let's do a mental exercise. So I'll present some simple machines and let me know how many scenarios these machines have. Okay. So here's a simple machine. It only has two switches and two settings. Maybe one is, so I know you can set the switch to on and off or high and low, right? So it's only two settings and there's two of them. How many scenarios do you have? How many ways do you think the different settings can interact with each other, and maybe different ways can go wrong? All right. So right. So most of you got it. There's four, right? On, uh, off, off, on, right? How about now? Three switches, three settings, maybe low, medium, high, and then there's three of them. I don't know. There's three different settings, right? Right. So it's nine, three to the third power, right? So from four, it became nine, just because we added a couple of additional features, or a couple of additional um, yeah, a couple of additional features or specifications. How about now? Uh, five switches, five settings, right? It could be very high, high, medium, low, very low, and then there's five of them. How many settings? Nobody's gotten it. Yes, it's 3,000. Thank you, Maria Tibon. It's 3,125 scenarios now, right? 5 to the 5, right? So um, this is what we call combinatorial explosion. Um, every time you add something to a system, to a machine, to software, the complexity doesn't grow linearly with whatever it is you're adding. It grows exponentially, right? That's why it becomes every little thing. Yeah, so maybe writing little bits of software, little programs, you can still control the bugs, or you can watch out for the bugs, you can fix the bugs. But even even uh, even smallish programs that aren't so big, you already start to hit this i- very quickly. You get to hit the ceiling in complexity if you have no if you haven't disciplined yourself in writing software in some disciplined way, right? Normally the people who survive learning how to code are those who learn how to write their code in some disciplined way, right? um, Very quickly you hit the ceiling in you can no longer keep up with the complexity because it grows exponentially. It's not linear, right? So you're talking about um, every time you add a new feature, or maybe the requirements are vague, so the programmers they try to they make the software too complex because they try to anticipate all the requirements because it's poorly specified. um, every line of code, every technology you try to mix and match there. um, the amount of data that you can change, pwede naman read only, but they make it read write, so that introduces more if you make something that could be read only to read write, that introduces again another level of uh, possible permutations, right? um, so keeping code simple. Some of the things I teach are the 3-second rule, which I learned from one of my clients. He said, "Oh, if I can't understand a method, any method in 3 seconds, you have to rewrite it." All right. So um, writing methods in a simple, expressive way that any other programmer who reads the method within 3 seconds can understand. That's something we should work at. Okay, if it's not understandable by somebody else in 3 seconds, we have to rewrite it. It's not clear. It's not clear and simple enough. Do the simplest thing that could possibly work. There's always more than one way, right, in programming to do something, and well, in life in general, and software projects, many aspects of software and life. So we always try to find the simplest way. It means it's related to the other one. You ain't gonna need it. Um, don't try to think of what you don't need to do. Right? Do I need to add this getters and setters, or do I need to do it now? Sometimes it's about uh, there's uh, there's a problem that programmers sometimes have. It's called speculative generality. We're always speculating, hey, maybe we need this, or I read this in the requirement. All right, maybe we should probably do this and do that. All right, so um, there's speculating what else we need, even, and then instead of actually helping, sometimes people think, oh, we should anticipate things, but that doesn't really anticipating often doesn't help in software development, because we end up adding things to the software that just contribute to making the complexity explode. um, Using trusted libraries and frameworks. In school, they teach us to code as much as possible. But in professional software development, you actually want to avoid coding. You want to reuse existing trusted libraries, because these have been tested over and over again. These are running in millions of lines of thousands of other software. They've been called lots of times, so they're well tested, right? So The more I tell people, the more senior programmers are usually the ones that want to avoid uh, not because want to avoid coding as much as possible, not because they're not good or they don't enjoy it. They probably love coding and they're probably much better than anyone there. But they know that writing new code introduces risk, so it's always more reliable to use trusted libraries and frameworks. I'll talk about information expert pattern and domain modeling. Um, information expert pattern, the class with the information should be the class that does the work. Um, so uh, so whoever has the fields. So a lot of times you see programmers, they separate. They're able to separate uh, um, the fields, the different fields into classes. They might be able to do a nice, well thought out. Um, they understand the entities and they model it, but when they actually try to but when they actually write the methods, they put all the methods in one place and they have these large god methods. It shouldn't be that way. You should for the behavior, uh, when the behavior should be written in the class that has the information, that has the fields. Okay, so that implies breaking up routines into smaller routines in that operate in the same class as where the fields are. So that's and which is basically the basic definition of object-oriented programming anyway. The combination of of operations with the data structures they operate in. Um, right. So this leads to smaller and simpler code that's easy to understand and maintain. And then domain modeling. What's domain modeling? Um, one of the problems uh, one of the problems that happens all the time is developers and business people don't understand each other, right? They I remember when I was one of the first times I was a project manager, I was supposed to gather requirements and I couldn't understand what this banker was saying. And then at the end, after maybe an hour she was talking, I asked a stupid question: what does debit and credit mean? And then she looked at me as if I was stupid, because that's the most basic thing in accounting, and I didn't understand everything and asked this most stupid thing, right? It's like I was asking, what does ABC mean? Um, but that's because, what do I know about accounting? I was never exposed to accounting. And same, if we try to communicate in our own the things that we find simple as technical people, it's we just lose the business people. So there's no common language that helps us understand each other. Eventually, of course, if you're working on a particular system for a long enough time, you eventually get to understand the business, and you start to be able to communicate with the business people. But then all that business logic is in a person's head, and of course, if that team member leaves, napipila yung team. The team becomes challenged because the the team member uh, leaves the with the team member, the domain knowledge, the understanding of the business leaves with the team member. So if business person comes, hey, I think there's a bug with invoicing, or I think there's something that needs to be changed with invoicing. All the other team members that are left, or if you're new to that company, oh, where's the code for invoicing? First of all, I don't understand what invoicing is. Second, where is it that does what this guy is saying, right? Um, so it's important that there's a common language and there's a way to document the business logic such that it doesn't leave. All right. Um, so basically, what we need to do is to create what's called a ubiquitous language. right? Uh, the same language in our code and with the business. We share the same language. And that basically means you model the business in your code, starting with the names of your classes, the names of your methods, the names, you don't use the nouns and the verbs and the adjectives of your business domain in your method so that your code itself becomes a model. So, and besides the names, of course, the different relationships, you can see that uh, the operations and behaviors and the relationships in the real world can be seen in your code. Okay, the the code itself becomes documentation, or at least a portion of the code. Often we call that the domain model, becomes documentation about the business requirements, the business domain. I mean, so that um, if even if I'm new to the team, and then some of the older team members have left, somebody's asked me about invoicing. Oh, invoicing. Let me do a search of some of the on the code and see look for the word invoice or invoicing. Um, there I can find, and then what will come up will probably be the code related to whatever this business guy was talking about. And so, okay, so I can see the operations, I can see the data on I mean, I can see the fields, the operations. All right, so I have a better idea of what this guy is talking about and how to address the business concerns, right? Um, because I've modeled things in. So if somebody asks me about debit and credit now, I know debit and I know a debit and credit, right? So it's you wrap debit and credit in a transaction, and the sum of all the debits and credits inside the transaction have to be zero, right? So if I look at that in code, so that's what a debit and credit is, and that's what an accounting transaction is. All right, so they have to be one thing. They can only be saved all or nothing. They have to be saved together, and they have to equal zero, right? Just by looking at the code, I have a better understanding of what the business people are saying. Okay, and then there's okay. So that's for some of the ways we address simplicity. Um, then there's defensive programming, where you prevent uh, invalid situations from happening. So, writing, I don't know if you're familiar with the term class invariants. Basically, you write your classes in such a way that, uh, at least, especially in the domain side, all the bad things or all the things that could cause bugs, you write it in such a way that they can never happen, right? If those familiar with Japanese manufacturing, it's the principle of pokoyoke, right? Uh, so I'll just run through this. Normally, when I teach a class, I have a lot of code examples of all these things, but I'll just do it in one big coding demo later on. So things like keeping things as private as possible, right? A lot of programmers, they automatically make things public, their classes public, their methods public, when they don't have to be. Always validating parameters. Never the first lines of code that one of the first lines of code any method you write should have, or any function you write should be validation. Try to avoid passing null. Prefer immutability for fields. So if something can be read only, if a field can be read only, even better. Or if you're not sure, make it read only first, and then you can always make it read write later on if you later realize it should be read write. Defensive copies. Maybe later on we'll see an example. Uh, Avoid modifying fields. Avoid putting setters, because then setters imply there's nothing stopping. There's no rules behind how a field is allowed to change. Whereas if you modify fields using some sort of business operation, um, then uh, then then it means fields can only be modified after following a certain set of rules. And then remove unused code, including unneeded getters. Um, and then there's this practice called refactoring. Some of you may or may not have heard of it yet. Uh, Refactoring, the so I think it was was it Martin Fowler or was it Robert Martin who said refactoring? You can think of the Boy Scout principle, which is leave the campsite cleaner than you found it. All right. So so refactoring is basically improving code without changing behavior. So uh, a lot of a lot of uh, a lot of uh, the a lot of times when we're teaching people how to code, or the focus of a lot of programmers is getting things to work. So very little is devoted to, or very little teaching, much less in actual practice effort into cleaning up code. So the practice of refactoring. So if you go in, you need to implement something. You need to implement a feature, right? That's fine. Focus on implementing the feature. It's very hard to worry about code quality when you're trying to get something to work, especially if it's a bit complicated. But after you do what you need to do to get something to work, it's not, that doesn't mean it's ready to be shared with your teammates. Um, you need to, before you share with your teammates, you have to clean up the code. So instead of the practice of what a lot of people think is refactoring is, okay, we're having so much technical debt, it's a mess, it's very hard to work with our code, let's do some refactoring. So they do some big bang rewrites of different parts of the code. Refactoring is better practiced a little bit at a time, something you do several times a day. After you implement something, every time you do a small implementation, before you share it with your teammates, you clean up the code. You take time to clean it up so that you leave it as clean or even cleaner than you found it. Okay. Code tends to get less maintainable every time it's modified. Um, you have to clean up your code after each task so that it stays uh, maintainable, right? All right. And then there's unit testing and test-driven development. So let's start with unit testing. So um, we know that changing code introduces bugs, and it's very hard to predict where the bugs will be. Um, and so you have to actually test the entire system every time you make a change, which is impossible with manual testing. And high level tests, like even if you do manual testing, or you just test using the user interface, even if you find the bug and all the steps to reproduce, you won't be able to. It won't tell you the source of the bug, right? It's very hard to say where the bug is, even when you find that there's a bug. The 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 test results won't tell you where exactly the errant code is. Um, Unit tests are tests on just one specific method. So if you're write enough unit tests, um, one you can one bugs can be pinpointed. Okay, so if a unit test fails, you know that's where the bug is because it's only watching one method. You should only be looking at that one method where the unit test is. And two, unlike manual tests, that it's very expensive, takes a long time, it's very difficult to write unit tests. Um, it's very difficult to run manual tests. With automated tests, you can run them, just keep running them all the time. Especially unit tests are tests that are normally in memory, that are basically in memory, you can they're usually done in less than a second or in seconds. So you can run comprehensive set of tests uh, several times a day. Tests are end up becoming your documentation. So for when I'm looking for um, when I'm looking at documentation to understand something, or I'm looking at Stack Overflow to understand something, right? I go straight to the code examples. I don't read all the words and stuff. I go straight to the code examples to understand the solution to my problem. And that's what unit tests are. They're code examples. So you so with a unit test, you can leave that to you can tell the new programmer to join who joined the team, just joined the team. Hey, here's our unit test. If you ever need to know how to use our code, just look at the unit test here. That's basically how to use the code. Um, Teams are easier to manage because through unit tests, because you know if what they're forced to prove that their code works. So as a leader or as a manager, you know if if your developers are delivering things that are working. Uh, Team leads can reject code without satisfactory tests. Okay. So that's unit testing, but what's test-driven development? Okay. Normally, we write some code and then we write some tests after we test. The normal mindset of testing, it's something you do after you uh, build. You build and you test. With test-driven development, you write the test first. All right. So, uh, so why do you want to do that? Because you want to focus on design instead of implementation. So you take a designer's mindset. Uh, Normally we teach our students, right, when they're just beginning the program, oh, write your pseudocode first, and then after that you write your code. Um, that's basically similar to what unit tests are, um, or writing tests are, only it's in code. Okay, so pseudocode can check if the behavior you wrote in the pseudocode complies with the actual code you wrote. But tests, since they're code, they can actually verify. So it's a very it makes your coding more deliberate because you are specifying again. It's no different from writing pseudocode, right? But this time you're writing real code. You are specifying the behavior of your code. Okay, so not only do you end up with tests, you become very deliberate in how you write your code. Okay, and you put yourself in the shoes of another developer who will use your method. So sometimes, so when you're writing a unit test, you write the test first. You see, oh, my method, it's too long, or the method name's not clear, or there's too many parameters. Since you're writing the test, you experience how your code feels, what it feels like to use the code, right? So before uh, you punish your teammates with how bad your code is, you experience it first, and then you realize, okay, I think I need to change this, I need to change that, in order uh, to make the code easier to read or easier to use or less error prone, right? If you build things first and then you test it, even if you find out that oh, your code is not so good to use, maybe you won't be, you already took the effort. It's a lot of effort to change the code. Whereas if you realize you need to change the design of your code early on, then it's not a lot of effort to modify it because you haven't implemented your code. All right. All right. So test after is actually harder. A lot of programmers, because they're not used to test driven development, they write their tests after they build their code. And then by then, besides being lazy to do it, you've probably by then written your code in such a way that it's very difficult or not even possible to test, right? Okay. So I like to use the 5-step model in test-driven development. So I start by writing a test, a particular test scenario. So normally for um, when I have a method that's worth testing, normally you'll have multiple scenarios, right? So I write one small specific scenario. I don't try to capture everything in one test method, just one small scenario. I define it and then I watch it fail. Why the heck would I need to bother to watch it fail? Because that's how you test the test. If you haven't written anything and it works, it means there's a problem with your test. um, then we write just enough code to get the test to succeed. Okay. Uh, we try to practice, do the simplest thing that could possibly work, right? Try not to write more code than is needed. We end up practicing this using test-driven development because we're guided by our tests. We don't. We end up not over-engineering the code. Um, and then we get, of course, we try to get the test to run, as well as we check if we broke it anything else. So we run all the other tests. And then the last step is refactoring. So part of TDD is refactoring. So before we move on to the next scenario or a next task, we clean up. Look for ways to leave the code better than we found it. All right. So, and then normally I have them implement group projects. And then in the group projects, the requirements tend to, I give the requirements incrementally, like every week or every meeting, there's new requirements. And sometimes the requirements introduce changes. So what I said, oh, this part of the requirement, it's not going to change, then I actually change it, right? Um, so they have to react. They have to make sure their code is maintainable because um, their sometimes the requirements can be very different from one iteration to another, and I have them submit using version control, and that's part of their grading, how they properly use version control. All right, so let's work on. So I'm gonna introduce a project. Here's the if anybody in the future wants to do copy, here's my build file. It's just basically JUnit as the dependency. Here's the requirements. It's a simple enlistment uh, domain model. So that I'll just be building the domain model. So just because we have limited time, no UI or database. So here's the requirements. The student is identified by his or her student number, which is not negative. Student lists one more sections. Student may have already previously listed in other sections. A section is identified by its section ID, alphanumeric. Student cannot enlist in the same section more than once. The system makes sure that the student cannot enlist in any section that has a conflict with previously enlisted sections. The section is in conflict with another section if schedules are in conflict. And then here's stuff on how the schedules are defined, right? The other bullet points, we probably won't have time to do that in our exercise. All right, let me switch to my IDE to uh, work on the code. Right. All right, everyone can see my IDE, right? So I've written out my requirements here. All right. So let's do things. Let's start with, I'm going to do things one bullet point at a time, right? To keep things simple, I try not to, of course, I start with reading the entire specification doc, and of course, I read background information, say It's I remember when we had to work on something for a power company, we had to do a lot of background research on 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 power, energy, pricing, etc., in order to be able to provide a good domain model for our client. So of course, I start by reading the requirements, all the requirements, and doing a lot of background information on the domain. But when I actually attack the 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 code, I try to attack it just one small thing at a time to keep it simple. Um, so let me start with just the first line. A student is identified by his or her student number, which is non-negative. So, all right, I talk to my teammates. Okay, I think teammates, I think we have to create an entity called student, right? Yeah, I think that's a good idea. All right, I'm going to create an entity called student now. All right, so I'll go create a class called student here. Okay, after consulting with my teammates. There's no need. I wait until maybe, probably this class will need to be public because it seems important enough to be needed in other parts, in other packages outside of the domain. But I always wait. I practice Yagni. You ain't gonna need it. I don't do anything until I find that I need it, right? So here, in the case of making this class public, there's a strong chance I'll need it to be public. But until I run into the situation, oh, I need to call it from the user interface side. I need to call it somewhere else, and it probably should be public. I don't do it. Madali namang idagdag yung public. But if I make it public and I realize it's a mistake, I shouldn't have exposed it. Now there's some bugs that I wish if if it wasn't public, these bugs wouldn't happen. It would be very difficult for me to take back that uh, that decision. So what's the easier mistake to fix? It's easier for me to make something more public when I realize later on it needs to be public, rather than to make something public and then I realize it's a mistake. Mahirap nang bawiin yon because now, there's so many things depending on it being public, right? So I won't make it public until I run into a need to make it public. All right. Um, so there. So next, what does it say here? Um, a student is identified by his or her student number. All right. So okay, so there's a number. It says here it's an integer. All right. So uh, let me put a field, right? Let me put a field that would it's an int, and then I'll call it heck, why don't I call it ID? All right. It's supposed to be the identifier. You think this is a good idea, or is there a better way to, or are there better based on based on what we've talked about so far? Is there a better way to write this particular field? Yeah. Why did we call it ID when it says in the requirements it's supposed to be called student number, right? So let's work with our ubiquitous language. Otherwise, we won't have documentation in our code. All right. So that's right, Dominic. Student number. What else? What else have we discussed that we should probably do for this particular field? Okay. Why should we use long? Because the student number has 10 digits. What's the Okay, ano ba yung maximum ng mac, how do you know? Does it say there? Did it say that did it say the requirements that it's 10 digits? How do we know that it can't cater to the entire length of the ID? Or are we speculating? Uh, right. Why car? Why long? Where in the requirement says that we need a long? Unsigned. How do you make an unsigned in Java? Wala pa yatang unsigned sa Java. Unsigned in. Why make it string? How do we know it's going to increase? Okay, I think we're speculating. I think some of you are speculating. Speculative generality. Right. All right. String that. See, okay. Here's so a lot of you are going into speculative generality. So again, you start to think of, okay, we probably should do this because of that. Okay, so you guys are speculating again. So that's one of the common sins that lead to complexity when we speculate on the requirements. There are things that are implicit. Say it's not written, but in accounting, debits and credits should always be zero within a transaction. All right. Um, but there's things that but outside of things that are like laws in the domain, right? Then it's speculation. So we have to distinguish between speculative requirements, implicit requirements versus speculative requirements. So I think a lot of the things you're concerned about are speculative. Okay. Right. Okay. What else do you think we need to do for this field? Uh, ask the student number format. Yeah, it's important that we need to ask the client. Although at this point, they already said it's an integer, right? The requirements already said it's an integer. Right. So very good, Ivan. It needs to be private, right? So our first instinct when we're creating fields is to make it private. All right. We can't make it static because if you make it static, then you share the field across all objects, right? So all the students in the school share the same student number, right? Uh, okay. Um, all right. And then the other thing that I mentioned is prefer immutable fields. I should have specified, prefer immutable fields. So as a preference, we always make fields final. All right. Why final? Because so many reasons why fields should be final. One, it's simpler. When something is read-only, then it's less complex than when something is writable, right? When something can be written, then you know when you're debugging, oh, what value did this become, right? Second is especially and that problem becomes even more pronounced when you're in a multi-threaded environment, right? So if it's already complex enough trying to keep track of the value of something that changes in a single thread, but if you're dealing with hundreds or thousands of threads hitting that field, and you don't know, one thread is trying to read and suddenly another thread changes the field, and then you end up having a problem. Okay, so by instinct, uh, until you really get to a situation where you realize um, it shouldn't be immutable, then prefer to make your field uh, mutable. Again, it's easier to, oh, this field should have been mutable. So let me delete this. Now it's mutable, rather than rather than um, it's mutable and dang, I'm having so many issues, so many race conditions. I probably should make this mutable. And so I put the final back. I put in final, and then it breaks so many things because so much of the code is expecting this to be writable, right? So many things break. So it's a harder. So it's an easier fix, easier mistake to walk back from. Make something read only, and you turn it read write, versus you made it read write and then you realize it's a big mistake, and then now it's very hard to fix that mistake, right? Because you'll break so much behavior. um so uh so of course now it's not compiling because you have to initialize it with something, but we can just put a construct, we can have it initialized in the constructor so that it compiles, right? Student, notice my constructors also I don't make it public. So int student number. All right. So so all right. So let's look at the requirements. We have it private, we have it final, we have something that represents. All right. Uh so okay, some of you have been concerned about this part. Let's making it non-negative. Okay, how do we make this? How do we make sure that uh, actually the fact that it's final makes a lot of sense for a student number, right? So if you're a student, up to now, right? When I go back to school, I tried doing grad school back in school. I still had the same student number when I went back, right? So it makes sense that the student number is final. But in any case, by default, we prefer to make things immutable. Okay, so now we want, so for this part, it needs to be non-negative. What should we do to make this non-negative? There's no unsigned in Java. There's no unsigned integer. Absolute value, we make it absolute. Well, but yeah, but that will. What if it was a? What if? How do we know the intention, or how do you know what would the reason be of receiving a negative value in the first place? What if? How do we know that we should make any negative value receive in a positive as a positive value? How do we know that's the right behavior? It just says make sure that the student number is always uh, positive, right? But it doesn't say we should accommodate negative values, um, and by turning them positive, right? I think that could be a dangerous thing, right? to to apply absolute value when we don't know, is that supposed to be what we're going to do, and then we end up saving that value, right? If All right, if what if condition are we talking about? What are we going to put? If what? Right. Okay, so we have to validate. So one of the things I talked about is we should always have the first one of the first few lines of code you should have in any method is validation. So in this case, well, we don't need to validate for null because it's a primitive, but we should validate that um, it the field is always let's see what the requirements say, is always non-negative. So pwede ang zero, wag lang negative. If student number is less than zero, throw new illegal argument exception. All right. And then let's say let's put some nice debugging information so that when something happens, we don't have to put any print messages. All right. We can just look at the logs and find out what happened by what information there was, what was the data being passed when the exception occurred. Okay, student number was not negative was plus student number. Okay, so there. All right, so we're still in one bullet point, right? So we've got a student, we've got a student number, where we've ensured that it's non-negative. Okay, that's good. Um, now, now there's one remaining requirement in this bullet point, and that is the identified. All right. So in Java, and it's probably the same in C sharp. Um, how do you? So this might be a bit Java specific or C sharp specific. How do you say this field? Um, if how do you say that if this value in this object is the same as this value in this object, they are the same object. Okay, so how do we do the how do how do we say that in right? Okay, so one of the three things every domain class should have is equals hash code and to string. All right, so I always make sure. So not only does the equals fulfill a requirement, it's also something, it's also a practice that we should have for domain models where we always override equals hash code into string, both in Java and in C sharp. Okay. So let's generate the equals method because it's too much brain power to come up with one's own, even if before we used to come up with our own. Okay, so there's the equals method. So now the student number, if two student objects with the same student number have the same student number, they represent this, they are the same student, they're equal. If two objects have different student numbers, then they're not the same student, right? And then another good practice in Java and C sharp is to always override in domain classes the toString method. Okay, so return, I'll make it say like student number um, student number. Okay, there's a question, getter, right? Do we need getters? So some people, as soon as they write a field, they put getters and setters, right? Is there a need for a getter? Right. There's right now I don't see a need for a getter, so I'm not going to put any code that um, I don't need, right? Because I'm trying to fight complexity. I know every little addition I put increases the complexity by a large amount. Okay, so let's see. Is there any refactoring I can do? I should do here. I have some validations. I implemented some of the required methods for domain models, equals hash code into string. All right. So I've implemented this. This task is done. Check, right? And I've done some refactoring. Now I'm ready to commit this to my version control. Okay, git commit, git push, shared with everybody. Okay, so I think this is ready to be shared. So I've shared with my teammates. Okay. Now let's move on to the next requirement. Student enlists in one or more sections. The student may have already previously enlisted in another section. All right, in other sections. All right. So, all right. So after talking um, my teammates, hey, I think we need to have another entity here, right? I think there's an entity called section, right? And then there's some sort of one-to-many relationship between student and section, or many-to-one, right? A student has many sections, I think. All right, okay. And then after I get my teammates' permission, maybe we do some drawing on the board, some UML or some entity modeling. All right. All right. I think we should add another entity here. So let's create a class called section. Okay. And again, I remove the public. I don't need that. I don't think I need that yet. Maybe later on, but until I get that, uh, I I know I need it, I won't create it. Okay. So now um, we implement this requirement. A student has, well, let's start with the fact that a student has sections. All right. So we do some drawing, right? Maybe you can do the crow's feet, or you do the asterisk, however you do the notation. Let's implement that. The one to many, one student has zero to many sections. So we implement that in Java using a collection. Okay, private collection section, and let's just call this sections. All right. Um, let's have an import statement. Import Java. All right. Um, oh, I already, I jumped already. So here, of course, we make it private. And again, by default, we make it final, right? Um, and then, uh, and then we need a way to initialize, because the requirement says, well, he might already have previously enlisted section. So it makes sense that in the constructor, we have a parameter for the section collection, the sections collection. All right. So maybe what we can do, well, let's do the straightforward assignment. This dot sections equals sections, right? And then let's see what's good validation. Maybe let's check for null, right? I don't know what else we should validate, but obviously we don't want to be passing around nulls. So let's have at least check for null. If sections equals null, throw new. I like to use null pointer exception when I get into a null. Sections can't be null. Okay, always some helpful debugging message in my exceptions. All right. Um, and then so let's stop with this. Okay, so not yet implementing the whole requirement, just the part where a student has sections, and he might have some previously nested sections. So we have this parameter in the constructor. Let's do some refactoring before we move on. Okay, so just with this field, just looking at this collection field and this collection parameter, focusing on that, what do you see could be a problem here? What issues? So let's talk about defensive programming. How can there be an invalid value here? Okay. Can you see what invalid value can happen when you have this collection? Um, what's the problem here in this collection? Let's see. collections with nulls inside. Yeah, we can validate, like we can get rid of the nulls, right? Maybe it's not sections dot remove right. So the collection might have nulls. Okay, we've gotten rid. But what else is the problem? There's no check for registered sections. I'm not sure what a registered section is. Wait, let me try to illustrate with an example. Okay, maybe where can I find this example? Wait, let me look for it here. Let me share another. Let me share this example. New share here. All right. So for example, I have this simplified version of the student. I just have this collection, right? Is that section? Sections. All right. All right. Let's not include this first. So if you notice, yung parameter may pinanggalingan siya, right? So here we have this collection that was passed into the constructor, and then of course naset yung field ng constructor, naset yung field yung object. Notice what happens. Okay, so here we have the collection sinet dyan, and then we check we check if we check the values, right? And then notice what happens when I add to this original collection. Okay, so let me add. So let me run this. It's not easy to see. All right, so here, notice the original collection. So obviously, it's ABC. Syempre yung field sa loob, ABC din yung laman. Nung ginalaw natin yung yung nasa labas, pati yung nasa loob nagalaw. So hindi talaga siya encapsulated, right? Kasi nagagalaw, since we still have a reference to this collection, pati yung collection sa loob ng field, nagagalaw siya. So delikado. Okay, you can't ensure that it's not in an invalid state because it's not really encapsulated, right? So, so this is where we have defensive copies. So here, if instead of assigning it directly to the field, can somebody mute the yeah, if you're not talking, please mute. Okay, note if we create a copy instead. All right, so if we create a copy instead, notice if we run this, notice yung original, syempre nababago siya, right? But the one inside encapsulated siya, right? Encapsulated siya. So hindi siya nagagalaw kahit nagagalaw yung pinanggalingan, right? Kasi kinopya lang natin yung laman. We didn't set it as the field itself. Okay, so we created a different collection, and that's what we set in the field as the field. Okay, the copy and not the original. Okay, so so that's what a defensive copy is. Okay, so let me go back to the to our enlistment code. So here, instead of setting this directly and then having the danger that an outside influence, right? Parang politika natin, no? That an outside influence might unduly change or affect the field inside. Then um, we should instead uh, we should we should create a copy. Okay. So one is we use the copy constructor, right? Array list. So that's one way. All right. So we can uh, so now ngayon we're just copying the elements. Okay. So there's two ways to when dealing with collections. Uh, you can use the you can create you can define the copy construct you can use the copy constructor here, right, to set me as much as possible. I like to do it upon declaration. I like to have if possible I already like to set the field, right? So me what I can do is, again, either way is fine, they have the same effect. What I do is um, array list. So here I create an empty array list, and then instead of uh, creating, so ito, I already create an empty array list, and then here I do an add all, right? So either approach is fine. They have the same effect. I just have a preference for um, setting, if I can declare, if I can initialize upon declaration. I usually prefer that. All right. So good. So clear ba why a copy constructor is important, right? So it's only important si student number di kailangan because it's it's when with student number it's a primitive. It's always passed by value, right? And many other objects, they're immutable, like strings or integers, local dates. They're immutable. You don't need defensive copies. But things that are mutable, like collections, which is why it's better. We always prefer immutable objects. Things like collections, things like java.util.date, delicado to because if you have a reference, if there's outside the object, there's a reference to your field, then your field can get modified. All right. All right. So we were able to do the part where we established the one-to-many relationship between student and section. And then there's a way to initialize the sections that the student already has already been has already listed in, but we haven't found a way to actually enlist a section. So a student, since we have this collection, um, a student will gets to enlist by, let's create a method, right? Some maybe we can call it add section, and then it gets a section, and then uh, sections dot add section. All right, is that a great way to all right, is that a great way to define, are you happy with the name of the method, add section? Because we're adding a section, right? Or is there a better name for this method? Add student section, add class. Let's look at the requirements. So we're trying to implement this. Right. Okay, it already says that the operation is called enlist. All right. So that's probably what the business users use. So let's use that word. Okay. Enlist. All right. All right. Okay. So we should do some refactoring. Um, let's see if probably we don't want this null. So again, let's have some validation. If section equals, so we want to avoid passing null. All right. Okay, so I think we can check that off. Anything else to refactor? Parang okay na, wala na. So, okay. Let's check this off and then let's share it with our teammates. Git commit, git push. Let's go on to the next requirement. A section is identified by its section ID and it's alphanumeric. All right. So let's go to the section class now. And then, so it says section ID. So it already says that it's called a section ID. So that's what we'll call it, section ID. And then it's supposed to be section ID. And it's supposed to be alphanumeric. So obviously it can't be an integer or anything like that. So it has to be a string. Okay. And then dapat automatic na by default, private final for a field. All right. Then let's add the constructor so that it compiles. All right. And then let's see. I need to make it alphanumeric, right? Oh, okay, alphanumeric. So I need to prevent things that are not alphanumeric. So if section ID needs to, it shouldn't be it, or it should, there should be some regex to make sure that if it's not alphanumeric, matches. Okay, now I have to add a regular expression. Oh no, regex, that's my weakness. Okay, I can never. Buti na lang may Stack Overflow. Okay, I'll go to Stack Overflow and copy whatever I find there. Is that a good enough solution? Well, I'll probably, if I'm gonna do regex, I'll just copy from Stack Overflow. But is that enough? Just copying and pasting? You know, maybe it's right, but how am I? How am I sure? Okay. So some of you are good at regular expressions, but still, okay. Say you're very confident of your skills in regular expressions, but there's also the part where you have to prove it to your teammates, right? How do you prove that your regular expression works, right? Do you expect your teammates just to trust you that you're good in regular expressions? Right. So you have to write some unit tests. Okay. All right. I'm good in regular expressions, but I need to prove it and I need to document it. I'll write some unit tests. Okay. So what are the scenarios? Well, there shouldn't be any spaces. There shouldn't be any special characters. Oh no, now I'm just writing all the unit tests. It's making me dizzy, right? There's a lot of scenarios. Okay. I'm feeling lazy. All right. So now, okay, so now I know I have to so I have to fulfill this requirement, but fulfilling the requirement, it seems like a lot of work, right? Is there a different way? Is there another way? And this is when I say this is what separates the junior programmers, the junior software engineers from the senior software engineers. Okay. Yeah, Stack Overflow is good, but again, some of the people pointed out, as long as you can justify it with unit tests, then with enough unit tests, then that's fine. You can write any code. You can copy any code you wish as long as it's justified with unit tests. But the thing is, there's so many scenarios, and we don't feel like writing out the scenario. So, what else is what will separate the junior programmers from the senior programmers from the junior programmers? What do you think? Comments. If the code isn't readable in the first place, then the comments, sometimes comments even lie, they mislead you. Right? Solid principles. All right. Yes, Benedict and Justin. Use an existing library. All right. Let me change the screen I'm sharing. All right. So the junior programmer or the junior software engineer uh, will make everything algorithm or a programming problem, and they'll start coding. Okay. A senior software engineer in his experience in many projects, even if he's 10 times better than the junior, knows that it's more prudent to look for a reliable library. So maybe he'll Google library Java library or for uh, checking for alphanumeric, right? So okay, and then um, after if you keep checking, you'll eventually end up with one of two libraries: the Apache Commons library and the Google Guava library. So normally I prefer Apache. So uh, let's go to so you'll probably end up with a class called Apache Commons string utils. All right. So Apache Commons string utils, it has exactly what we're looking for. Alphanumeric checking, right? So there's a method somewhere here is alpha, right? All right. Perfect. Okay. So um, Apache Commons, it's used in thousands, if not millions of lines of projects. It's been running. If there's any bugs here, it would have been discovered already. All right. So writing writing the code ourselves and having to justify it with a lot of unit tests, let's just use the library. So uh, so here, of course, we need to find out what to add to our build file, right? So Maven Central, um, what is it? Apache Commons Lang, right? That's the library that we need to include. All right. It says here for Gradle, uh, we need to add this. All right. So now let's add this to our code. Let's go back to our code. Let's go to our Gradle, build file. Oops. Okay. We add it to our code, and then it downloads from the internet um, the dependency, right? And now we can use that dependency to implement um, our check. Uh, So if uh, it's not uh, string utils that is alphanumeric section ID, and then throw new illegal argument exception. What are we gonna say? Section ID must be alphanumeric. And then, of course, we have to include the value that was errant so that we can debug when a problem occurs. All right. All right. So we have the check. We've uh, we've satisfied this requirement. Section is alphanumeric. All right. Let's look for ways to refactor. We're not ready to share because we need to refactor. Okay. Um, another thing that we can take advantage of in Apache Commons is if you notice um, so these validations are that start to get quite noisy, diba? So there's another parang paulit-ulit and it's starting to clutter our code. There's another class in Apache Commons called validate. So it contains common validation. So validate is true. This code we have here is alphanumeric. And then instead of always having to specify, it throws illegal argument exception. It already knows that that's what you want. You just need to provide the error message. All right. All right. So we can replace. So let's replace that. All right. We can shorten it by having static imports. I like to use static imports so that I like it that it's not too long. Okay. Okay. And all right. So we've got the requirement going. Again, just getting things to work isn't enough. We need to refactor. This shouldn't be null, and it shouldn't be blank either. We don't want it to be white space. Fortunately, the validate class has a single method to check for both null and white space, so not blank. Okay. All right. Oh, we missed a requirement. It's identified by its section ID, right? So it means we need to use this as the basis for our equals and hash code method. Generate hash code and equals. All right. And then we again, it's also we should always have toString method, right? The three methods all domain classes should have toString, hash code, and equals. So public string toString turn section ID. Okay. Anything else to refactor? Did I miss anything? I think I'm okay. All right. So I think we've cleaned this up enough to be able to share with our team, our teammates. So git commit, git push. All right. Then let's go to this part. A student cannot enlist in the same section more than once. All right. So that's where's this red? Sorry, forgot the semicolon. All right, so let's go back here. Student cannot enlist in the same section more than once. So let's go back to the student class, and then we should be able to So somehow, when we enlist, we should prevent enlisting in double enlistment in the same section. Any suggestions? Any suggestions on how to prevent double enlistment in validate using? Yeah, we could do that. We could have maybe um, we loop through all the sections. No, we can. It's easier than that, right? We don't need to loop. It's if sections dot contains the section, the new section, then we throw new, I don't know, some sort of exception, right? And then we have a message. Um, all right, that works. But is there an even better way or more succinct way, or maybe instead of yeah, okay, or either we throw, or maybe we just want it to end silently because it's not a big deal, so maybe we just have a return statement here. All right, so as opposed to throwing an exception which terminates the program, maybe we just want it to just not do the operation. Okay, right. So for that's right, Amos. So we could just, instead of actually writing any code here, why don't we just uh, take advantage of the Java collections library, right? So what's the collection where, what's the type of collection that where all the elements are always unique? So they're sets, right? So if you're, so why bother writing any more code when you can just replace, uh, you can use the appropriate collection, right? Okay, so that's it. We've accomplished that one. Git commit, git push. Um, then the system makes sure that the student cannot enlist in any section that has a conflict with previously enlisted sections. What does that mean? A section is in conflict with another section if the schedules are in conflict. Oh, okay. So this is referring to schedule conflict. Schedules are as follows. The days can be either Monday, Thursday, Tuesday, Friday, or Wednesday, Saturday. All right. So naka-pair, right? So um, you always so there's always 2 days apart, uh, and then the periods are always 8:30 to 10, 10 to 11:30, 11:30 to 1, 1 to 2:30. Okay, so it's always an hour and a half. There's 6 periods, and then we talk to our BA, we talk to the client, the business school owners, this or the school registrar, the school business. Yeah, for the last 20 years our school has always been like this. Okay, I see. Okay, those are the schedules. There's no chance of overlaps because notice the periods never overlap, right? So the only time there's a schedule conflict is if the schedules are exactly the same, right? Same day, same period. All right. All right. So all right. I think so. Now I can't think of a way to do this in a very simple approach, right? That makes it um, stupidly simple, right? So um, I think it's time for us to apply TDD because there's some level of complexity already. All right, so let's start using test-driven development. Um, so before I uh, let's start by writing a test. So by convention, if the class we're testing is called student, we have to call the test class student test. All right. So um, we just add test to the so that it's organized, right? When you're looking for tests, you want to know where the tests for student are. You look for a class that's called student test. All right. And then by convention, we use for the test methods, we use the the name of the method we're testing as the beginning or the prefix of the test method. So the method we're testing is enlist. So our test method has to start um, with enlist, right? Okay, so void enlist. What are we gonna call it? So here we need to create a method. What is it? Enlist. Say uh, enlist with enlist with schedule conflict, right? Schedule conflict. All right. So that's our test method, right? But this is a negative scenario, and I've had experience where I've built all the scenarios for negative, preventing invalid values, but I ended up blocking even the valid values. Okay, so I made it a habit where before I create a test, or if I'm going to create a test with a negative scenario, also have to have what we call a happy path or successful scenario. So before I implement this negative scenario, I'm going to create a test with the happy path or the success scenario. Okay, so void enlist uh, enlist sections no conflict. All right. For when I tell people I teach or train, when you're a bit challenged to what to write in your tests, you follow the given when then. You can use given when then, the given when then pattern to help you come up with your test scenario. Okay, so it's like your pseudocode. Okay, so so here we want to create a test. So we want to create a test that that tests for no conflict. So how do we do that? Well, maybe we can have a student who enlists in two sections with no conflict when the student enlists in both sections, then uh, both sections should be present in the student and no other sections. Okay, so just those sections and no other. All right. So that's our pseudocode, our given when then. So now let's implement. So at this point, this behavior already exists. We're able to enlist students, right? We're just so this isn't TDD because TDD is for behavior that doesn't exist yet. Mamaya we'll do TDD, but right now we're just writing a test. So this is just unit testing, okay? Because we need to implement the success scenario. So let's do that. Let's say student student equals new student. Uh, let's have the student number 1, and then uh, it pass in an empty collection of sections, and then let's have two sections, right? Sec 1, um, section A, and then section, and then, all right. And then we'll have the student enlist in both sections. Okay, student dot enlist in sec 1, and then student dot enlist sec 2. Um, and then we need to verify that these sections are present, right, in the student. Um, so now we have to be able to retrieve, right? So student dot get sections. We need to retrieve the sections. Oops, we haven't implemented the getter, but now we have a need. Okay, we have a requirement. We have something that where we need the getter. Okay, so it now we now there's a reason to add a getter, but not before that. Okay, so let's generate the getter. Source generate getter. I'm so lazy that uh, I need to use a code generation. Okay, no, not get student number, get sections. Generate pa lang mali. Get sections. Turn sections. Okay. Okay, I ended up not using the generation. Okay, all right. Notice I didn't make it public. I don't doesn't need to be public. I just need it to be accessible from the test. All right. So all right. So now we need to say that we need to say that uh, these sections are present, right? So assert uh, true sections that contains all list dot of sec 1 and sec 2. All right, so we need to make sure that they're there. Okay. Import. And we need to make sure that they're the only ones there, right? Assert equals. So we want that the size is 2, right? Just 2 and nothing else. Sections, we don't want it to be less than 2 or greater than 2 because we want just 2 sections there, right? So let's wrap this in an assert all. Um, okay. All right. So now let's run this test. Well, let's to see if so it should work, right? Because this is we already have the code there. Successful. See, it's green. Build success. All right. All right. And this one wala pang laman, so obviously successful. Okay. Um, all right. So this is successful. Let's see what we can refactor. Just because it's working doesn't mean we should move on. Let's see what we can refactor. Um, so here, what can we refactor in this method? This is the only new code that we introduced to the student class. What can we refactor? Any any suggestions? What can we refact? What do you think we can refactor here? Anyone? Um, Anything else? What do you think is the danger here? You see anything dangerous here? So let's defensive copies. Yeah, right. Exactly, Jacob. Well, you direct messaged me. So, right. And Gabriel, since we don't have a defensive copy here, once we return a reference, we can modify the collection, right? So that's dangerous. We break the encapsulation. So we should return a defensive copy again. Okay. Doesn't have to be the exact same. So even if this is a set, there's no reason to say, there's nothing that says we need to return a set as well, right? So here, let's just use the simplest collection because the requirements don't say we need to use anything complicated. Um, so the easiest and the most lightweight to instantiate an array list. So now let's check if our tests still pass after doing that refactoring. All right, it still passes. Okay, so all right, so um, all right, so now we've got test pass. Okay, we can git commit, git push. So now let's actually do some TDD. So let's implement behavior that does not exist yet. All right, um, so finally some TDD given, when, then. All right. So given, so what's this? Again, we should probably have given uh, one student and two sections, but this time, and two sections with the same schedule. Okay. When the same thing, the student enlists in both sections, right? Then let's see, what behavior do I want when the student enlists in both sections? Then an exception should be thrown. I think what I want is an exception to be thrown. Uh, uh, should be thrown at the second enlistment. All right. So notice it's a very deliberate way of uh, defining the behavior. Okay, so um, sometimes we're writing code and we realize we're not even implementing, or what we think in our head is the actual requirement, and it's not. We end up actually creating the wrong behavior because we've been working with assumptions. Here, you're very deliberate. This is the behavior I want from the method. So this is and in the process of being very deliberate about creating defining the behavior, you're creating documentation and you're creating tests, right? All right, so let's do that again. One student, two sections, but they have to have the same schedule. Oops, hey, we haven't defined schedule, right? So we got to define schedule. Let's go back to section, and then um, we need to define schedule somehow. All right. So we have a field called let's call it, let's call the field schedule. I guess that makes sense. But what would be the type of schedule, right? What do you think is a good type for schedule? Int. Why int? So if I pass in schedule 2054, how's that? I'm not, is that string, right? So if you pass in Monday, Thursday, 8:30 to 10 as a string, then I'll have to parse it, right? I have to parse the string. What if it's an invalid string? What if I pass in, I don't know, my mother's maiden name instead of instead of a schedule? So how many validations? What kind of validations do you have to write to make sure we never pass in an invalid schedule? Right? A date, yeah, date. Well, java.util.date. We want to avoid using that as much as possible because that's what for one, it's a mutable, it's mutable, and two, it's very difficult to use. Okay, ints could work, I suppose, but then you'll have to make sure you validate that you don't pass in ints. Amos said enums. So yeah, I suppose there's only so many. We can have 18 enums. That's a possibility. Uh, if it's a primitive, what primitive would you use? Right. Yeah, so a couple of people suggested enums. Um, right, that could work. We could have special, there's 3 periods, there's 6 periods and 3 days. That's only 18 options. You know? So pwede ngang enum. All right. Yeah, but I wouldn't use a string because a string, ang daming possibilities to, you have to write some complex code to validate. You have to write some complex tests to validate, to make sure your validation, uh, you've justified the code for the validation. So what I would do is I'll probably create a class. So maybe some others would prefer to do something else, but I'll probably create a class for schedule. Okay, so let me create my schedule class. All right, and then I'll just make it follow the structure defined here. Right, there's a days and there's a period. Right, and then where was I? Asan na si schedule? Yun. So I'll have 2 fields, right? So I think it makes sense for me. Um, I'll just have one field for days and one field for period. Okay. So now the question is, what are the what ano naman yung type ni days and period? All right. So ako looking at these requirements, tatlo lang yung days, tatlo lang yung period, 6 lang yung periods. Okay. So di ko na after talking, you think, to my teammates and business analyst and the client, uh, you think pwede bang i-hard code na lang? O sige, okay naman kasi hindi naman 20 years na nga daw, hindi pa nagbabago. O sige, hard code na lang natin na uh, let's use enums. Wala na naman sa schedule. Ay, ito, schedule. Maybe si days, let's have an enum for days. So MTH, TF, and Wednesday, Saturday. And then let's have another enum for period. All right. And then I'll say the first period, I'll call it 0830. Of course, you might have a different, you might just call it period 1, period 2, period 3. That's fine too. I'll call it based on their start time. H All right. And then, so this will be period. Of course, we always make it private and final. All right. Let's, but okay, isa lang. Anyway, okay. Okay. So the nice thing with enums is yung validation lang na kailangan mong gawin is checking for null because enums will never be invalid except for null. That's the only possible validation. That's the only possible value that they can have that's invalid. Okay. All right. Okay, so that's our schedule. Let's put the usual equals method. Generate. Of course, it makes sense to use both days and period. Does it make sense for the equals method to just use one of them? Um, and then here for the toString, public string toString, return. I'll just say I'll print out the days, then I'll put a space, and then I'll print out the period. Okay. Okay, so now we have to add this schedule to section, right? All right, so uh, let's add that parameter. Soup schedule. And then, of course, we don't want it to be null. So not null. All right. Ah, all right. Here we go. Um, so now let's go back to our. Of course, we broke some tests, right? Uh, so we go back to student test, and then we see that now we have to add a schedule, right? So let's add that schedule both in the old test and in the new test. So now, so this one, their schedules are different. New schedule. Um, days, let's have Monday, Tuesday, period. This is, let's say, this is 8:30. And then for the other one, let's let's make this period 10 o'clock para walang conflict, right? And then just to be sure, this is TF, Tuesday, Friday, right? So now it's impossible for the schedules to have to be the same schedule, but here we want them to be the same schedule. All right. So now the student enlists in both sections, right? Student dot enlist in section 1, student dot enlist in section 2. All right, so enlisted in both sections. And then we want to check that in the second enlistment, there should be an exception thrown. Okay, so let's bring this down here on the second enlistment. And then we'll say assert throws some sort of exception. So let's just put this the most general exception for now. Uh, where if this method is called, right? So when that method is called, all right, and the two sections have the same uh, have the same schedule, we want there to be an exception. Okay, so now let's run this test. Okay, we watch it fail, right? We want to see it fail. Okay, good, it's failing. If it succeeded, there's a problem with our test. So you want to watch it fail because that's how we test the test. Okay, expected java.lang that exception to be thrown, but nothing was thrown. All right, so now we have a working test. It's expecting that it's expecting that uh, an exception has to be thrown, right? Um, so here, let me clean this up so that it's out of the way. Not now. Okay. All right. So here, now let's implement that behavior where we're checking if there's a schedule conflict. All right. Uh, so we have to loop through all the sections, right? Let's loop through all the sections that for each one, uh, for each current section, what we want is uh, if they have the same schedule, if same schedule, then we throw an exception. Okay, so here, if uh, cur section that get schedule, oops, we don't have get schedule method in section yet. So let's let's add that. All right. Um, let's add that to not get. Let's add that to our section class. Right. All right. Uh, let's resume writing out the method. Oh, it's here. So we got the schedule, and if they're equal to the section that the other section schedule, then we should throw some sort of exception. All right. Uh, so let's see if we've got it, if the test is working now. All right, so now it's passing. So we have the right behavior. If the two sections have the same schedule, then uh, it should throw uh, an exception. Okay, so now let's refactor. Um, let's see. Let's see what we can refactor. Let's have some. Well, one of the things that I experienced while writing this code is I felt annoyed that every time I create a student class, a student object, if the collection, if it doesn't have any enlisted sections yet, I still have to pass in this collections, this empty collection. Okay, so the test helps me design. So another programmer will probably be annoyed as well at this kind of design, this parameter that I'm forced to pass in that I don't need. So let me change my code, right, based on what I learned from the test. So I'll create a convenience constructor, student. It just takes in the student number, and then so and then I just call the other constructor, right? Passes in the student number, it passes in the empty collection. All right. Okay, so that's my one refactoring. So I go back to my test, and then I can get rid of this. And, all right. And then I think that's more convenient and expressive. I'll run my test just to make sure I didn't break anything. So while you're refactoring, continue to run your keep running your tests as you refactor. Otherwise, you might have broken something while you're refactoring. So what else can I refactor here? So here, one of the things I don't like here is I got confused, which is the current section, which is the new section. So renaming is one of the most important refactorings. I'll change the name refactor. I'll call this new section, right? Instead of just section, so that I don't get confused which section I'm talking about. Okay. All right. So now it's clear we're talking about the current section and the new section. And then another thing that should be obvious to you guys by now is there should be some sort of uh, error message, right? That will help us debug. So uh, um, we should uh, schedule conflict between section section um, between current section, uh, cur section, and new section, new section at schedule. Okay, so they're the same schedules. It doesn't matter. New section dot get or current section dot get scheduled. All right. So there should probably be a message. And actually, after reading so many exceptions, right? Maybe I should differentiate this particular one. Maybe I should create a custom exception. Uh, One is when I'm reading a bunch of logs, at least it will tell me right away what kind of it's more descriptive of the problem, right? If I'm reading through a bunch of logs and trying to look for an exception. Another is programmatically, I can do something different when it's certain types of exceptions. Maybe I want to show a message. Other types of exceptions, I want to do something different, right? So maybe instead of runtime exception, I should probably create my own exception that's more descriptive. So here, let me go back to the test. Instead of just expecting any exception, I will say that I want to expect an exception called schedule conflict exception, right? Of course, that doesn't exist yet. So let me create that class, new Java class, schedule conflict exception. Extends, of course, it's an exception, extends runtime exception. And then I want it to have a constructor that takes in error message. Okay, so let's have it have this constructor that takes in the error message. All right, so so we created the change. Okay, so let's run this test again. Obviously this will fail because now it's expecting a different exception. Expected schedule conflict exception, but we threw a runtime exception. So let's fix that as well. So now we'll have it throw schedule conflict exception, right? Schedule conflict exception. Oops. Um, and then now let's run the test. In fact, let's run both tests to make sure both tests are working. Okay. All right. So both tests are working. We didn't clobber anything. Uh, okay. Any other refactorings that you guys can propose? Any other refactorings? Okay. Based on what we've covered, has conflict method. All right. Yeah, that's it. Yeah. Um, that's true. That's good. What principle? So Gabriel, your suggestion is correct. But what principle are we? What practice are we following by creating that has conflict method? Why did you recommend that? Okay. Who can recall the slide on information expert? What does information expert say? Uh, what does information expert say? You guys remember? Right. The class with the information should be the class that does the work. So in this case, where's the information for this behavior of checking if there's a schedule conflict? All right. So which is the class that should be doing the work? Which is the class that has the information? Right. The class that has the information should be the class that does the work. So which is the class that has the information? Yeah, the section class. All right. So this behavior is in the wrong class, right? So we should move this behavior over to the section class. So let's see what we can do. So maybe in the section class, we can introduce a Boolean, maybe. Boolean has conflict. Return. Right. Okay. Now let's apply it here. Current section dot has conflict with this new section, right? Now let's see if everything works. Let's run the tests again. All right, so everything works, right? Still same behavior, right? Um, but I think there's even more that we can move, right? So at this situation, is there a need for this this every time we check for if they have uh, the same um, if they're the same if they have the same schedule, I think, at this point we want to do the same thing. We want to throw uh, this exception. Okay, so maybe I can even this part I can move it to the other side, right? So what if instead of just checking, returning a boolean, so I have maybe void check for. Okay, so we've moved everything to the section class, right? So uh, we can get rid of all of this, and then instead we can just say something like cur section dot uh, check for conflict with other, right? With new section, right? Or anyway, sige, I was checking something. Anyway, let me just use that. So here, uh, let's see if this works, right? Again, let's run our test to see if we broken anything. All right, everything successful. What else can we refactor? We're no longer, this is dead code. We can get rid of this getter, right? Um, I tried to avoid leaving dead code. And see if I broke anything by removing that getter. Okay, nothing broken. All right. Um, so that's all the refactorings I can imagine. Of course, would let let's put an X here. XX mission accomplished here. Everything. Okay. All right. And then normally the rest I leave as exercise for the student. And of course, marami pa yan over I do changes to the requirements and things like that. Okay, so that's it for my so that's it for what I wanted to demonstrate, right? Any questions? Any question? Did you guys learn anything? Okay, so no questions. Okay, okay. I guess I should.
Yes
Okay,
po, we did. They learned.
okay. What did you guys learn? What stood out? If
There's actually a question. Will we be
there's a
able to get
question.
the
Oh, sorry.
files?
Oh yes. I can share the slides. I can share the slides.
There you go, Abram. Mr. Cullen can share the slides.
Yeah.
External libraries don't.
As long as they're reliable libraries, they're trusted libraries. So what did people learn? If you guys learned something, what stood out besides the external libraries? Okay, refactoring. All right, that's good. Exception handling. All right. Okay, I'll turn things safer coding practice. Okay, I'll turn things back um to teka, to Cyril again. Uh Cyril, I'm done, I guess.
Thank you so much, Sir Callan. I'm pretty sure that everyone actually has learned a lot from this one. Yes, that's what they're saying. I have learned a lot. Thank you, sir. It's an ending. Thank you, sir. That I'm seeing on the chat box right now. So thank you very much, Sir Callan, for that very, very insightful and actually it's very detailed, right? So that's why everyone is very thankful for your time, sir, and for the knowledge that you shared this afternoon. So if the last call, no questions for Sir Callan? Really? Okay, Sir Callan, thank you very much for detailed explanation of how to do clean code. That's from Rayu Saplad. So he was very specific with all that, and there's really a lot of appreciation over there. They're also asking if the recording, the video recording will be accessible after the session. So
Uh sorry, did we record? Sorry, was there a recording? I don't know if we
the
recorded.
video recording, yes, sir, we did.
Oh, we did record.
We
Okay.
have a
All
recording
right, sure,
after
great,
the
great.
session. So we will be able to share the recording, perhaps post it on YouTube.
Okay.
Yeah,
Sure,
so
sure.
at least everyone will be able to access this session. So unfortunately, everyone, every session must come to an end. It's a pity, but it has to end. So I hope everyone learned a lot today. To everyone who's here and who stayed with us, thank you very, very much. And we hope to see you all in the next activities of the Philippine Software Industry Association. Once again, Mr. Callan, thank you so much for your valuable time and knowledge. Have a good evening and stay safe, everyone.
Okay.
For the ones asking for the certificates, yes. Yes, we do. We also provide e-certificates only though. So yes, we can provide you those certificates.
All right. Okay. Thanks everyone. Thanks, Cyril.
Thank you, Sir Callan. Have a good evening. We'll be closing it now in 3, 2, 1. Stay safe.